In this video, we'll be going over happy numbers. So write an algorithm to determine if a number n is happy. So a happy number is a number determined by the following process. Starting with any positive integer, replace the number by the sum of the square of its digits. Repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which does not include 1. Those numbers for which this process ends at 1 are happy. So return true if the input value is a happy number, and false if not. In our first example, we're given this 19, and then we continuously find the sum of the square of its digits, and then it does reach 1, so we return true. Let's go over the thought process. So let's break this question down into two parts. So the first part is finding the square, or the sum of the square of its digits inside a number. Let's call it x. Now, how can we find the sum of the squares of its digits? So we can process the digits inside x from right to left. We can retrieve the current rightmost digit using the modulus operation. So we have the current rightmost digit is equal to x modulus 10. Then we can remove the current rightmost digit using division. This will allow us to process the next rightmost digit. Now the next part is detecting a cycle. We can use Floyd's cycle detection algorithm. So in this case, we are going to have two variables. So if it's slow, this number will change one step at a time. And when I say change, we're going to find the sum of the square of its digits one time. And then we have fast, so this number will change 2 steps at a time. And in this case, the same thing, we're going to invoke the sum of the squares of its digits twice on this value. If slow ever catches up to fast, this means we have found a cycle. Now let's go over the pseudocode. So we're going to create a method first, a helper method, to allow us to find the square, or to find the sum of the squares of the digits inside a value x. So what parameters do we need? We need x, the current number we are processing. And then what's the base case? Oh, we don't have a base case. So in the method, we're going to create a variable sum. Then we're going to while x is greater than 0. This means we still have digits to process. We're going to retrieve the rightmost digit. So d is equal to x modulus 10. And then we're going to increment sum by the square of d. So d times d. And then we're going to remove the rightmost digit. X is equal to x divided by 10. Then we can return the sum. Now we can go back to our original problem. We're going to create two variables. We have the slow, initially n, and fast, initially n, which is the input value. So while slow is not equal to 1, we want to change slow twice. I want to invoke the method one time on slow, and I want to set slow to the results. And then we're going to invoke the method twice on fast. Then I want to set fast to the results. Then if slow is equal to fast, this means we have found a cycle. We're going to break from the loop. Then we're going to return true if slow is equal to 1. Else return false. Now let's go over the time and space complexity. For the time complexity, we get O of k times 10, which is equal to O of k, where k is the number of loops. So we have k times 10 because in each of the loops, we process the digits inside a number, and At most, the number will be 2 billion, and the maximum number of digits inside 2 billion is around 10 digits. Now our space complexity, we get O of 1. Let's go over the code. So we're first going to create a method, sum of square of digits, inside a value. Let's call it x. And then we're going to create a variable sum. And then while x is greater than 0, we're going to retrieve the rightmost digit. Then we're going to increment sum by the square of d. Then we're going to remove the rightmost digit. Then we can return the sum. We're going to create two variables, slow and fast. The slow changes one step at a time, and the fast changes 2 steps at a time. So while slow is not equal to 1, so we have slow invoking this method once in slow, and we have fast invoking this method twice inside fast. Then if slow is equal to fast, we have found a loop, we can break from the loop. Or we have found a cycle, so we want to break from the loop. And then we're going to return true if slow is equal to 1. This means we have found a happy number. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.